Hi guys, welcome to Learn Electronics Repair, and my friend Detlef is here again today for another sponsored video by PCBWay.com. In this video we're just going to have a chit chat really, so this is probably going to be one take, no editing.
Yeah.
Let's have a chat about a few things, really about some projects we're working on and ones we want to work on. I also asked in the previous video for any suggestions on things you'd like to do. I picked on one. There may be more, but I haven't looked back at that video for a week or so. So if you weren't quick enough, that's probably why I haven't mentioned you on this one. Yeah. So anyway, we're going to start off, and this is where Detlef comes in straight away, because do you remember this thing, guys? This was last month. We built, or rather I built, this little inverter. It's supposed to have a transformer on here.
Mm-hmm. Yeah.
But although it oscillates, the outputs, I think they're called Q and not Q, like anti-phase, nothing comes out of the chip on those outputs.
Yeah, and there was the thread under the video that was, maybe these are rejected parts. And I was sitting in freaking cold Germany, and I watched the video and I thought, wait, I'm going to the university anyway, so I checked the stack over there. And yeah, now the University of Düsseldorf is sponsoring Learn Electronics Repair.
I hope they know this.
Don't tell them.
You've done it now. You've said it.
Dang it.
Damn. So we're going to see first whether this chip actually works. I mean, I made 2 videos about this, went into every possibility, and came down to defective chip. And somebody said in the comments that at some point he bought a large batch of these and found they were all the same, with the same defect as I'm finding on. I have 10 of them. So without any more messing around, shall we have a quick look at the pin out of this thing first, so you guys will know what we're talking about. One moment. Yeah, I found it here, guys. So this is the data sheet. So the problem I found was the oscillator out on pin 13. The chip was oscillating, but Q and not Q is supposed to be an anti-phase to each other at half the frequency of oscillator out. And it was a bit less than half because there was no frequency on those, so there was none. I was running this chip at 12 volts last time, so we can go to the same. And let's have a look. So I've set my power supply to 12 volts. Oh, a blue light came on. It's interesting. It's drawing 10 milliamps. Of course, you guys can't see it, can you? So let's just press the button. Well, look, the blue light came on.
That's light. Did we have a blue light before?
I believe we did have a blue light before, because I think this is just on the power in, yeah.
Okay, so...
Okay, so the question is, let me just set a camera where you can see the oscilloscope. We're doing this on the fly, guys, so let's have a quick look.
We really haven't tested this out.
No, we've not tested.
Completely unscheduled here.
Yeah, so...
I didn't have time to shave. Like I normally do.
Well, shaving is overrated.
Yeah, totally.
So, let's see. Let's make this a bit bigger. You can see it. Hopefully you can see that, guys. All we need to know is, does this oscillate? Do you like the crazy angle that's at? It's like off a... Do you remember the 1960s Batman series? If you guys don't remember...
Not anymore, man.
From the Batman series in the 60s, all the sets were like leaning over it.
Yeah, they were.
Crazy angles, like it was meant to be like a cartoon, yeah.
Very creative ways back in the days.
I actually watched a bit of that, just recently on...
Yeah, we're starting to watch all these strange old stuff again.
Yeah. Anybody remember Starfleet?
Don't go there.
X-Bomber. I've watched them all.
Starfleet.
Alien Raiders just past Gemini. Okay, so what do we have on our chip? What's it doing? Let's have a look. So we have 12 volts coming in.
Like 12 volts, yeah.
And there's something going on.
The 12 volt is oscillating. This is not good.
No, that's not good, is it?
No.
But it shouldn't have any oscillation. And the ground lead is on.
Ground lead is on, okay.
12 volts.
Okay.
Pin 13, there should be...
Okay, there's a thing going on. Nice.
There's a thing going on. That is oscillating. It's like every other one's are different.
Yeah, and this is probably the same as we saw on 13. So this could be a power supply problem.
So what's happening on 9?
Nothing.
Nothing.
That's no good.
And 10. Oh, is it 10 and 11? Maybe I'm wrong. There's 10.
And this is half the frequency, yeah.
And there's 11.
And they're stable.
And they're stable. So this chip actually works, guys. Yeah.
Get the people closer in.
So this is actually working.
This feels like a Sunday live stream.
If I can have another hand free, I can probably get the two of an anti-phase. Let's just put the other...
Can you do that?
Yeah, we can. Let's put the trace on there, yeah. Look, we have a nice
here.
yellow one as well.
In old Batman style, I do this a bit in
Okay, yeah. So was it 10 and 11, yeah?
Yeah, I think so. The data sheet is not. I know.
There's one of them.
Oh, yeah, we can't do the thing there.
Yeah.
Okay.
And I think it's set to trigger on the blue one, so
It will be. Yeah.
So that's one. And let's go to the other one.
So.
Oh, sorry, I slipped.
No, it was very good visible. And truly, your chips were fakes, rejects, or something.
Yeah.
Because this one is working.
This one is working.
Crazy stuff.
Okay, guys, so that settles that one, yeah, from the previous PCB way. The problem was, quite simply, the chips were no good. Which is crazy. I mean, I can't believe they're fake chips. I think they just... Because what are they? They are fake watts, you know. It's like some chip would have to be made out of that functionality. I think it's just a defective batch of chips.
Yeah, and either way, defective or rejects.
Or rejects, yeah.
Where you go for, okay, we have the basic function, and if nobody needs the inverted digital outs,
yeah,
that will do.
Well, yeah.
Yeah, but for our case, this didn't.
It didn't. So, guys, 4047. If you need one for a project, be careful where you buy it from.
Yeah, we had the same problem. Remember the 80 Tiny 85 I bought from AliExpress? Yeah, same there. So, and these are chips that are below $1. So it makes sense for somebody to fake these chips. This is
again, could they be defective ones?
No, we never found out what they really were.
We never found out what they really were.
They were simply rebranded something, and we were lucky that they didn't blow up anything.
They just didn't work.
Yeah.
Okay, so guys, that's that done. Let's move on, or should they say, how do you say it? And now for something completely different.
Monty Python.
I will, by the way, find a suitable 12012 transformer. I don't have one. I have a 18018. I think this chip will run at that voltage.
Should do.
Yeah, so I'll have a look. So we'll do a follow. So we'll do a follow up. Okay, why can't I say follow up? So we'll do a follow up, but at least it oscillates now. Okay, so that's that. Now, talking of oscillating, this is the little breadboard I put together for the video about pulse width modulation. And I had a really crazy idea. So when I have crazy ideas, the first thing I do is speak to Det. Yeah. And say, Det.
Lucky me.
Yeah, lucky me. So what I said to Det is, we'd like to build, or I like to build, an educational board. I'll show you what I mean in a moment. To make a Class D amplifier. But using like, you know, discrete components. Well, a 555 timer.
You want to tell people what you mean by Class D amplifier?
Oh, Class D amplifier. We talked about this on a previous video, actually. But let me show you the schematic of what we're trying to build. And then we'll talk about how we actually want to implement this. So I'll just take us over to the internet again. And back to the internet. We found a few versions of this. Somebody well known did this.
Actually, Greg Scott did a design for that. It's a 6-year-old design. And when I looked at that, I thought, okay, this looks weird and this looks strange. And there is probably at least one error in there. And then we found this thing, or Richard found this thing here.
So the one that Great Scott did had he used like a 7404 inverter, but only
overkill.
One of the 6. We looked at this and we actually talked about using 2 op amps, didn't we?
Yeah.
And having effectively, I'll tell you how this works and I'll tell you what we thought. So, or Det thought.
Yeah, we should probably explain what this thing is doing.
Okay, so what does this thing do? Well, we have a 555 timer running at high frequency. He's saying greater than 250 kilohertz. Okay?
You need this for the sampling rate there.
Fair enough. We have audio coming in here, and basically this forms a comparator. So it's comparing the voltage on the slope going up and down with the voltage of the audio at that time, and generates a pulse width. So this effectively makes a pulse width. It's a pulse width modulator basically, and the width of the pulse will vary with the amplitude of the audio at that point in time. And this thing is a MOSFET driver with 2 MOSFETs, and the speaker goes to here. If you didn't follow that, don't worry, because we will build this and we will explore how this works. Now, you can see that he's using a triangle wave, okay, into the pulse width modulator effectively. I've also seen circuits that use a sawtooth wave, and I don't actually know what difference that makes.
Both of us doesn't know, because both of us think it won't make a difference at all.
No, so we're going to actually make this thing with 2 555s in slightly different circuits and a jumper link, so we can actually switch between sawtooth or triangle.
Can I show the people what the difference is? Yeah.
If I can find the other one, you can. Yes.
Oh yeah, we don't need, because this is pretty easy to explain.
Okay, you go for it.
They're using the 555 is this clock generator. You all know the 555, right? Right. You know it. Good. If you don't, 555, Google it. And normally you use for the cap here. This is the timing component, and the R1 would be my charging discharging thing that normally is connected to VCC, so 5 volts. And what they're doing here, they're using the output to recharge and discharge the cap. So this should be approximately a triangle. We hope. We haven't tested this before.
No.
But we simply can probably do some clever jumpering over here. Because if I connect this R1 here to VCC and connect the discharge here to this here, we have a sawtooth.
We do have a sawtooth if we put a diode in. Let me find the circuit that I actually built. So 555. This is on the breadboard we have at the moment. Okay, and that is actually my circuit. So this one, effectively, you have all the 3 pins connected together, which you say. We have the capacitor. This Zener diode and this transistor, this is a constant current source.
Yeah, the transistor is an emitter follower here.
Yeah, so this gives a linear slope basically here, And you'll see this doesn't have the resistor fed across from there. It's all from VCC, like you say. And this diode here is to clamp the waveform near enough to 0. So, and that gives a sawtooth. I've actually built this.
Probably would have 3 jumper blocks up the. Would that work for you, or would I want to have some separate?
I'm easy. I make 2 separate ones, but I'm quite easy.
Yeah, we probably want to do some separate. This way, then I can simply choose between the 2 of them. By jumper. So going for the triangle, go for the sine wave, for the sawtooth.
And what we mean by an educational board is based on something like this. So this is a project I built a little while ago. This is IFPSAWHG.
IFPSAWHG.
And this effectively is an op-amp educational board for a teaching aid. And the thing, as you can see, the op-amp actually goes here, here, but the layout looks like a schematic. So when you're coming around with your test meter or with an oscilloscope, it's obvious where you're probing rather than thinking, oh, what pin is that? And then you're probing on the chip. And what we'd like to do is make a Class D audio amplifier laid out like this. So, of course, we're going to use PCBWave because PCBWave.com is sponsoring this video. Detlef first had a look at this and sort of said to me, Rich, this is a bit of a rabbit hole.
It is.
And the reason being, Det, is because of doing this sort of silk screen. Is that right?
Yeah. The when you do the PCB layout, normally you don't care about the silk screen. The silk screen simply tells you where goes what component. And you would never draw lines on them, and you don't draw symbols like an op-amp on this. So we don't need to have a clever way to draw this stuff and still fit in the parts.
So the idea is that the chips can go somewhere else, but the silk screen on the board is going to look something rather like we were just looking at.
Let's go there.
Let's go there. So we have 2 ways of doing this. One is to effectively make the silk screen look like this, with just the various test points on, and we'll put test points on these so you can probe them. Or the other way would be to make it look sort of like the schematic. So effectively all this would be drawn on the board, maybe not the power supply bit, but the other bits. But the components can be mounted elsewhere. So we kind of like, I'm open. I think probably that if we build it and do something that looks like this, that'll be more of an educational tool. So what do you guys think? Swarm intelligence is the word?
Yeah, let's go for the swarm intelligence. Let's see what the people want. This is not, we came up with it. When I saw this, I thought, okay, this is what I want to have on the PCB, because you can do test points, and we will have some changeable components over here for the triangle generator, for the...
So in actual fact, we have like triangle and sawtooth, and a jumper, which you can just jump from one to the other. Yeah. And
it puts us somewhere near there. And the audio input, by the way, would be simply a 3.5 mil jack somewhere.
Something like that.
And we probably put the MOSFETs not where they are right now. We probably put them in, where did we have this? Into these, we're not on camera.
We can get back on camera. So, I know what Det's, I agree with Det on this one. So, something like these. So, we can mount these near to the edge of the board, and the MOSFETs will plug into them. Just screw them down.
If you blow up something, you simply can replace them without soldering.
And the same with the ICs on sockets as well, because if it's an experimentational board, and we'll be playing around with it in different ways, maybe not just as an amplifier, but as a pulse width modulator that will drive various things like motors and whatever. So if we put the MOSFET so they fit into these, a pair of them, then it's once you've destroyed it, because you probably will do, it's easy to just plug some more in.
Happen to the best of us.
Exactly. And sometimes even to the worst of us.
That too.
So, leading on from that, this bit of a circuit here, this is the actual one that I built on breadboard. This was on the All You Need to Know About Pulse Width Modulation to Fix Stuff video. And this runs at about 8 kilohertz. Now, I've had this on one side for a week or so, but would you believe it still actually works?
Weird.
That's a bit unusual. You think something would have broken by now, but no, it still actually works. So what we'd like to try today, just very quickly, is to see if this will run at higher frequencies. Now, the fact it's all lashed together with bits of wire is probably not the best place to start with.
And 250 kilohertz is something.
It's something very high. So I'll power this up, and then we'll get the oscilloscope, and we'll see what frequency this is currently running at. I think it's about 8. About 8 kilohertz it was on. Okay, so if we get the oscilloscope once again with Det's amazing bit of
doing the
camera work, if I can find the right source. Okay, here we go. So there's one oscilloscope.
And by design.
We better connect the scope probe, hadn't we, really?
No, good idea.
Yeah, good idea.
I think you only need one this time.
I just need the one this time, So,
that's
my finger. Oh, I'm picking up the frequency just by...
Oh, you're already getting the radio tower.
I'm getting the radio tower. Near to this thing, okay, so...
Oh, there's something on there.
There's something on there. Let's have a look. So... this should be about 8 kilohertz. In fact, can we see here?
Oh, 8 point some,
8 point something kilohertz. So that's using a 100 nanofarad capacitor. Now, I actually want to change this. I made this quite easy, so the capacitor is actually just down here. So we should be able to unplug that. I suppose I ought to power it off, really.
You're chickening out here.
We only have one of these things.
Okay, this is reasonable.
So we can take this capacitor out. Okay.
Watching the master work here.
And I have a 10 nanofarad, a 4.7, and a 1. So this one is a 10 nanofarad. The original one was 100. So we're going basically. Where did I take it from? There and there.
So you switched from 100 to 10?
100 to 10. So this should be, we think, 10 times.
80 kilohertz.
80 kilohertz.
Oh, that's
well, it's certainly running faster. What we've got.
It is. Let's see.
And I'll just try to set the trigger a little bit. It's jittering, isn't it?
Yeah, it's not very
This is all these. Look, if I put my fingers on the wires.
Oh, yeah. This is. These are the antennas. Yeah.
These are the antennas.
But you're running 50 kilohertz.
50 kilohertz. Nice. Okay. So let's try. Go again. So this is a 4.7. Let's check. So this should give us. No, it's actually a. That was a 10, definitely. Yeah.
All right.
This one, I think, is a 4.7. Let me have a look while I have my fingers here. Yes, this is a 4.7. So we'll stick this one in. So you'd expect this to be about twice as fast again, wouldn't you?
Yeah, should be. So we should be touching somewhere around 100 kilohertz.
Well, yeah. So let's have a go.
Let's go. It's still oscillating.
And it actually, again, it has that nasty jitter on it. Oh!
All right.
I don't know how that managed to actually.
You're not triggering on. I think. Okay.
It just set the trigger on the.
Okay, this feels weird.
It feels weird.
I think the trigger is on the wrong channel.
I don't think it is, you know. We can turn the channel off altogether. I think Det might be right. No.
There's a second trigger over here. Look at this. This is hanging up in the corner there.
I don't think this is where we get to the actual triggering on this. I think we have to press.
I haven't used my oscilloscope in half a year. I have no idea how this works anymore.
I've stopped it.
Oh yeah, this works.
That works. So we can see it's
100 kilohertz.
100 kilohertz.
Yeah,
okay.
There's a nasty glitch down in the lower part, but I think this will work out.
Yeah, and then we can go. Shall we go for the small one?
You still have smaller.
I have smaller. So this is a 1. So if this is giving about 100, this should give about 500. Ooh.
Well, it should be somewhere in around 250 kilohertz then, I'd guess. This would be the range they are suggesting on the schematic.
It oscillates.
All right. So the chip is still there.
At 300. Oh, but you see how it's kind of flattening out a bit at the top and bottom now.
Yeah, they're not happy. Okay.
312 kilohertz.
Wow. Okay, this is fast. You know what? For educational purposes, this will do, I guess.
It will. And bear in mind, we've got all these
antennas. Yeah.
Antennas on here, so hopefully.
You know the socket down there in the lower part. This thing. There's a diode in there, right?
Yeah.
This is a silicon diode?
Yeah, 10400.
Can we try a Schottky?
If I can find my hands onto a Schottky, we certainly can. Do you think that'll actually deal with that?
This could be the thing to get the. I don't want to have this the socket down there.
Schottky, is it 1N5?
5119 or something?
5819?
Yeah, will work.
Let's see if I have these. If that's what I have here. I have a, looks like a 5819 to me.
Yeah, this is one.
Yeah, okay. If I can get in at this thing, so you can see where my diode is, it's kind of strapped across there.
These are the news for 4007.
So that goes one up from there, and that goes onto the bottom pin of that, okay.
Alright.
We can try
Don't
it.
kill the circuit.
No, I'll try not to kill the circuit. I've lost the diode. It's here.
No, not the diode.
I have lost the diode. Okay, so this goes up from one pin up there, and the other one's onto pin 5 down here. Let's have a look. Let's have a look to see what it does.
Again, guys, this is not tested. We haven't done this before. This is completely unscripted what we did. Oh, this is getting worse.
Is it getting worse?
Ooh, why?
Well, this is something we can play around on our educational board.
Yeah, true. Yeah, and the frequency has gone down.
Oh, it has gone down 192.
Yeah.
That's interesting.
Oh, that's bad. Oh, yeah. Okay. Don't use shotkeys on this one, guys.
Nope, don't use shotkeys on that.
No shotkeys.
Okay, so there's a rather unstable project we can play with. The main thing we really want to know from you guys is how you would best do this.
Yeah.
Yeah. How you would best do this.
Let us know what you think, how to do this stuff. I'm probably going for draw the stuff in false start and copy it over and maybe use some readable fonts in there, because I can't read this thing even under the microscope looking at the screen here. I can't tell this. The upper one looks like it could be R10.
Oh, 10 and yeah.
But I'm guessing here. So guessing is not good for an educational board.
Bigger fonts, and we think white on black.
Yeah.
Black PCB, white writing. Yeah, make the writing bigger.
Yeah.
Or do it like the block diagram you talked about in the first place. Yeah. Okay, guys, so that's that we'll be working on.
We keep you posted. When we got your inputs on this one, We will design the thing, and then we keep you posted in about fortnight.
Yeah, about
3
fortnight.
weeks.
Yeah, something like that.
We should have the design done then, and maybe already on the way.
Okay, so talking about designs, on the previous video we put out from the PCB way, or rather I actually did on my own, that one. I asked what you guys would like us to build. So go on to PCBWay.com, have a look at the shared projects.
Let's go there.
Well, we can go there now because one of you guys, let me unshake that cam first. Okay, he's gone.
Never
So
any fun here.
one guy who watched is Tim's projects.
Oh yeah, Tim.
Hi Tim, how you doing? So Tim came back and rather shamelessly suggested that if we were going to build a project, we should build his. And why not? Yeah, and why not? So let's have a look to see what Tim's project is. So this is Tim's project, yeah. Tim's hot plate PTC. So Tim's actually been in touch. We've chatted a little bit.
Yep. I talked to him too. Yeah, nice guy.
Yeah, very nice guy. So Tim, we're gonna do it. Yeah, you're shamelessly plugging your own project. Worked. So we're gonna build this, and we hope you can help us with the construction. But basically, this thing uses, from what we can see, these. So this is on AliExpress.
Yeah.
Is it the fan thing? 300 watt PTC heater with fan. We haven't looked exactly at your project, Tim, so you can come back and tell us exactly what we should use. And I'm wondering, actually, could we, because I know your project uses a triac to switch these, could we have, say, 4 of these and make like 1200 watts on a larger area if we're working on large PCBs? Can we maybe modify your project? So let us know, give us some links. In fact, Tim, I'm sure you'll be commenting on this video as to what we should actually be using. These, I think, are these are low voltage. I know yours uses the 240 volt. No, these are 24.
This is 24.
I know Tim, yours uses the mains voltage ones.
Is this schematics?
There are some schematics for this.
There's an instructable.
There's an instructable.
The schematics are probably there.
I'm sure they will be. Yeah. Oh, Tim, you have a video. So, guys, I'll link this video in the description to this one so you can have a look at what Tim is doing. Aluminium PTC heater. Oh, in fact, you're going to show us now what we use. So this is nothing like I was looking at.
Okay, perfect.
Okay, so we have those. So again, can we use like a few of them in an array to give like a hot plate? To say you could put something like a GPU on or a motherboard. This is the most useful thing to me. Okay.
Okay, we have some Arduinos, we have some rotary encoders, we have some displays. The Macs we need to order.
Yeah, but we've got a lot of this thermocouple.
The SSR could be a
solid
thing.
state.
Yeah, we need to find out which one.
Okay, we got to look at that one. Yeah. I'm sure the link again will tell us. I'm sure everything is here we need. Yeah.
Oh yeah, one of the big ones. Okay.
One of the big ones. Okay, so
yeah, of course. This is how it switches all the stuff. Yeah.
Which is why I'm thinking we can have more than one hot plate.
Yeah, with these ones, 25 amperes.
Yeah, exactly.
And they're running at this one runs at 24 to 380 volts. So, 25 amps at 240 volts. Yeah,
we could build something interesting.
We have some more. Yeah.
Okay, so that project, guys, I will give you the links in the description if you want to have a look at that in detail. That is something we are going to build, because I know a lot of you guys would find something like a hot plate very useful, especially a larger one, and they can be quite expensive to buy. So let's work out to see how feasible this is and if it actually makes financial sense. Yeah.
Oh yeah, true.
But to be quite honest, it makes a lot of fun. So that's that one. And then the last thing we just want to talk about is soldering irons.
Again, you had a video I took this week with soldering irons.
I did, but I have, you guys know, I have a T12 soldering iron.
A cheaper one.
Yeah, well, yeah, I have the El Cheapo. I have the T12. You see me using this all the time. I have the C210. You sometimes see me use this on very fine stuff. I have the El Cheapo one, which was the battery powered, which is this one. So this is the little 8-watt soldering iron I reviewed, battery powered. And I mentioned actually in that review that Detlef had also tried one of these, and maybe he would comment. But you know what?
Yeah, I was lazy. And we went to the parade this weekend, so
Yeah.
I have an excuse.
But however, you cannot be lazy now. So what was your impression of this soldering iron?
I actually sold a little board of mine, through-hole components with this, and you know what?
Yeah.
For €5,
Yeah.
this works.
Yeah. It's currently on sale at €4.19.
Yeah, this is way better than any of the gas-powered things I saw before, and well, if you don't have anything with big thermal mass, this works.
Yeah. I mean, I see this great for on-site work, obviously.
Yeah.
And keep it in the car.
Absolutely.
You know, if something breaks down, you need to solder something, maybe.
Yeah.
One guy said that this thing is totally useless. I actually completely disagree with that.
Absolutely.
It doesn't do everything, but it certainly ain't useless, because I was unsoldering SMD components with this.
Yeah, I saw that. Yeah.
And even quite large ones, yeah.
And I'd say this won't replace your soldering station. Of course not. It's not intended for this. But if you're a beginner and you don't want to spend a lot of money, and you know you want to have little components, not big components, this could be a good thing. For all the rest of us, keep it in your car, keep it in a field kit.
Yeah.
Because this is way better than having no soldering iron out there.
Exactly.
And this works. And you can step up the temperature if you need more thermal energy in there.
Yeah. Yeah, exactly. In fact, to be quite honest, guys, something else we looked at, and you know, you've seen this, the thermal camera multimeter. One of these and one of these in your toolkit, and you can do just about anything you'd ever want to do on site.
Loads of stuff, yeah.
Yeah.
Yeah, we're looking for whoever company is listening out there, build us a thermal camera multimeter with an oscilloscope in there.
Yeah, yeah,
Please.
exactly. Please,
Yeah.
please.
Gotchafix,
yeah.
Finerzi,
Gotchafix, somebody.
whoever listens, tool shop.
Make one of these.
Yeah.
And with the scope built in.
Yeah, get us a scope in there. 'Cause then you have
Even
everything in there.
Yeah. Even the type of scope, like the little Gotchafix one that uses the meter probes. Okay, it's only good for 12 megahertz, but it's good for a lot of work. Yeah.
When I was playing with that, I found that I need does 80% of the stuff I normally use, and you know me, I'm normally with microcontrollers.
Yeah, exactly. Another 20%, you'd have to take it to the workshop anyway. So
Yeah.
there you go. So anyway, the topic of soldering irons. So I have the C210. This is the Sugon T26D. And I was told that that is also compatible with the C245 handles. So I went and bought a C245. This is effectively a clone of a Weller. Nice big BC3 tip. This is like 90 watts or something. This is more powerful than my little KSG or T12. Beautiful soldering iron. And I plugged this in to the soldering station, and what happened was that. So the tip just got hotter and hotter and hotter until, I'm not sure it burnt out, but the thing was practically glowing, yeah?
Light emitting soldering.
Light emitting soldering irons, exactly, yeah. And without a thermal camera to emit the light, it emitted it. So I'd like to use this. I've got the handle. I've got another tip which I didn't plug into it. I then went and Googled the problem, or mentioned it on one of my videos actually, and a subscriber came back and said, yeah, I tried the same, they're not compatible. Okay, so I'd like to try the soldering iron, and I thought I'd like to do it on the cheap. So where did I go? PCBWay.com. Okay, let me show you what I found. I found this one. So this is a controller for the JBC 210 and 245 handles. So I can actually get genuine JBC tips, and they do fit in this handle. But obviously I've got the compatible ones as well, but they should be just fine. So this project, I have basically everything I need to build this one, apart from the PCBs. So let's have a quick look at this. Can we expand that? We've got a schematic.
Okay.
We can actually look at it.
I don't want to reinvent the wheel there.
We've already ordered the parts for this.
Did we?
Yeah. Remember, you had to get me some of these 7-segment displays.
Yeah, I remember. Okay.
So everything's...
So we have the PCB anyways.
No, we don't have the PCBs.
All right.
I thought I had them when I looked. I got the wrong PCBs.
Okay, that explains a lot.
Okay, guys, so we actually ordered the parts for this quite some time ago. I thought I had the PCBs, and when I came to put it together, I realised the PCBs were the wrong ones. I think they were for a T12 soldering iron or something else. So you can see here, it will take either the C210 cartridge or the C245 or the Weller RT. So it's quite versatile, actually. The thing runs on an 18 mega. Can you make anything much of this schematic, Det?
Yeah, the 18 mega is it's not an Arduino. Don't go and say, oh, this must be an Arduino. It's a similar processor there, and we can program that. I think we ordered a programmer for this, specifically for this project.
I think we specifically did, yeah. So we have everything here. I have the socket for the soldering iron, but I made a slight cock up there. I'll show you in a minute.
You see X2 over there in the top left corner.
This thing here?
Yeah, this is where we program the thing.
Okay.
Yeah, and we know how to do this, yeah. From there on, we know what to do.
So you know how to program that. We actually ordered these 7-segment displays. We couldn't find these on AliExpress.
I remember. We ordered this via Amazon, yeah.
Via Amazon, yeah. TL431. Yeah, yes, I remember now. We ordered all the surface mount TL431, 78L05. So we have everything to build this. TL431, has that been using a voltage reference here? Is it just...
Yeah, it is. AREF. So this is the input for analog reference.
Oh, I see. So we just use an A to D... I can't even say that word. A to D converter.
Yeah, and they're probably doing something where we get a reference signal back from the soldering iron.
Yeah, from down
the
here
chip itself, yeah.
Yeah. So does this 18 mega not have a built-in A to D?
It does have. I don't know why they're doing that.
With an external
you normally go for when you're using the AREF, the external one. You normally want to have more precision, or you want to have a different range. Well, you know what? We'll find out.
Yeah, and obviously these thick tracks here. This is the power circuit.
No, this is a bus. No, you're right. You're right.
Yeah. So effectively,
no, it's a bus. Look, bus. There goes bus.
No, there's 2 thick tracks. That's a buzz.
Yeah, and this is a bus.
And this one is the main power from the transformer through the pitch rectifier.
Yeah, true.
Through the, it's actually almost like an emitter follower, but with a MOSFET.
Yeah.
And into the socket for your soldering iron and back out.
Yeah, oh, look at this. The circuit completes here. It's a PWM. It's a
PWM, exactly.
Yeah.
So we have that.
Yeah, so we're driving the T2 with the PWM to give it a bit more power, and then hitting T1 with that. And we probably can go for IRF 399310. Some. This is a generic MOSFET.
Again, we ordered them. We've ordered everything for this because this is a surface mount project.
Okay, good.
And the sockets I ordered too. You see, they're just wired differently for the different type of tips.
Yeah. So we need to wire this correctly to make it work with the
245. Yeah, because I already have a 210 station anyway. Okay, guys, so that's something else you want to have a play with. That's the last one for today.
I really like this. This guy knows what it's doing. Look at top left. There's a one LM358U1, and he actually did the right thing here. He simply did this. He didn't leave the inputs open.
Yeah, nothing floating.
Nothing floating. So I like this very much.
Good. Okay, yeah, that's an interesting project, and this isn't too expensive to build. The main expense of this is the power supply, 12 to 24 volts at 5 amps. But I don't see why we couldn't just use... Can we use a switch mode in it? I mean, look, there's no capacitor on here. This is just pulse DC.
It is.
It certainly is.
Why?
I don't know. Again, guys, why is this guy using pulsed DC to drive the heating element of the iron?
From D1, D41, you will get a...
Yeah, pulsed...
A sine, upflipped sine.
Yeah, at 100 hertz or 50 hertz main. Why is he doing that? Do you guys see any reason why I couldn't use something like a 24 volt 5 amp power brick type thing or a 19 volt to run this, or even a PD?
The LM358 over here, U12, is connected to that. So we see what the.
Yes, but you notice here this is connected via an inductor and then a capacitor to smooth it. No, it's on 5. That's plus 5 volts. That's this rail.
Yeah, this is supply.
Yeah. There's 2 supplies. There's 5 volts and there is 12 volts.
Weird.
But the 12 volts only supplies this circuit loop. Here.
With D1 and D2, he cuts off the header there, and R3 and R4 with the RV1 makes a level there.
Yeah. Is it? Oh, hold
This
on.
is live, guys, so I've seen the schematic for the first time.
Yeah, hold on. Is he actually, because this is effectively pulse DC, is this thing somehow
This is detecting
the 0 point?
It must be. Yeah. And he probably switches on the. He does. Is this then a PWM?
It's on PWM, but this PWM could actually be running at 100 hertz. So this is like a chopper, which we used to use in the very old switch mode power supplies before we had switch mode power supplies. I think he's picking up the 0 crossing point here. Yeah. And then this chip knows when it reaches 0, and then at a certain point after that, he's switching this on.
Yeah.
No, it can't, because it's on the output of that.
Well, it's a MOSFET. I don't see.
Oh no, it's not. It doesn't matter. This goes back to the bridge rectifier. So this also has the pulses on here when this is off or on. He must be picking up the 100 hertz frequency from this, and then effectively chopping it with that. Let me draw on a piece of paper what I'm thinking, guys. Let me draw this. So, I hope you enjoyed this, because this is all real, guys. This is live, yeah. This is how we brainstorm stuff. Yeah, so what I think this guy's actually doing is he's got a bridge rectifier, yeah, plus minus. This is your AC. So coming out of here is twice the mains frequency pulses like this, yeah, going between 0 and whatever the peak is. And I think he has his microcontroller, okay, and he's detecting the wave, okay. So he knows when this is 0, and then the pulse width modulation, which is effectively switching a MOSFET, which drives this, yeah. So like kind of from here, you've got your heating elements, your soldering iron, yeah, something like that. Doesn't matter the order it's in, okay. And what he's doing is he's detecting when this reaches 0, and then waiting a certain delay to switch this on. So coming into this effectively is part of that half cycle.
Exactly. Just like what you would do with a dimmer.
Like you would do with a light dimmer. And then by moving this point, he can alter the width. It's a very primitive form of pulse width modulation without a high frequency oscillator.
I'm with you here.
And I think that's why he's using. If you put a smoothing capacitor in here, or your fed DC, it wouldn't work.
Yeah, this is absolutely true. I don't really get why he's doing that, because wait, I know why he's doing that. He simply can save on the big cap. He doesn't need the big cap.
He doesn't need the big cap. He doesn't need a high frequency oscillator for the pulse width modulation.
Yeah.
The microcontroller is just effectively measuring it knows the 0 crossing point is here.
Yeah.
And by setting a certain amount of delay before it switches that on.
Yeah. This is simply to save on components.
Save on components, and obviously the longer it delays, then the narrower this will be, so the lower power in the soldering iron. And he's measuring the temperature of the soldering iron with a thermistor, and then he's moving that point. That circuit is called a chopper. I know they call a bike that, and a rally cycle a chopper, but this was called a chopper because it chops chunks out of the main cycles. And this was used in TV sets right at the end of the 70s.
Okay.
Rather than using huge like power resistors to drop voltages, they used a chopper circuit like this. Yeah.
Well, we're going to build this, and we'll find out.
We'll find out. Yeah. So again, swarm intelligence. What do you think? And the last thing on this video I did say I would show you this. This will give Death a laugh.
I have no idea what's going to happen now.
So when I ordered all the stuff, I ordered some of these nice sockets for my soldering iron because it is the right size, and it doesn't fit in. Yeah, it doesn't fit. So I thought I'll order 2, and then I can plug either type it in wired differently. I can plug in whichever one I want. And that don't fit that. You think it might, but it doesn't.
Yeah, we need more plugs that are incompatible to each other. So
we need more sockets.
yeah, there's
More swarm intelligence. What do you call that plug? What's the socket for that? Yeah. Anyway, there you go. That was practically a live stream. I mean, we pretty much live streamed that. Yeah. Hope you guys enjoyed it. Let us know if you like this sort of stuff, or you think we should just actually learn what we're talking about before we open the mouths.
sometimes this helps. Yeah.
Yeah, sometimes it helps. But guys,
This is actually what we do in the shop. When we come out with new ideas, we simply brainstorm them like the way we did just now.
Yeah, with that circuit, yeah, and figured it out. Okay, so let us know. Comments below. Yeah. Remember, guys, how we do this. Silk screen, comments below.
Any good ideas are very welcome.
No, you got to stop.
Am I going to stop now?
And yeah, we have a vision. We're going to stop now. Okay, see you guys.
See you guys.